Alright, we're going to be talking about equivalent fractions. Let's look at this model right now. This model is showing a whole that is cut into 3 pieces. So if I were to shade in one of those pieces, I would identify this fraction as 1/3. An equivalent fraction is a fraction that looks different but is equal to another fraction, and I'm going to show you how this works. Right now I have it cut into 3 pieces. What if I took it and cut each of those thirds into another piece and just halved those pieces? What fraction does this now represent? Now there are 2 pieces shaded out of a total of 6 pieces. So 1/3 is equivalent to 2/6. They are the same representation of a whole piece. They were just cut up differently. Instead of having just 1 out of 3 pieces, I now have 2 out of 6 pieces. So that is the visual I want you to see as we're talking about how to actually do equivalent fractions. Equivalent fractions look different but are equal. And when we're talking about equivalent fractions, we're going to have something called the golden rule. You have to remember that whatever you do to the numerator, you must do to the denominator. And we're going to get into a process and you're going to understand what that means. And remember, our numerator is the number on top and our denominator is the number on bottom. The numerator is the pieces we're talking about and the denominator is how many pieces the whole was cut into. In order to do the process for equivalent fractions, there are 2 operations we get to do. So there's an actual process for creating equivalent fractions. We're going to use 2 different operations. The first operation is multiplication, and we're also going to be able to use division. Now let me show you some examples. In our model, I showed you 1/3 shaded, and then I took that 1/3 and divided it into 6 pieces instead of 3 pieces, and then it created 2 that were shaded. These are equivalent fractions because even though they look different, they do represent the same amount of the whole. I'm going to show you how multiplication can be used in this instance to have created this equivalent fraction. And remember the golden rule, whatever you do to the numerator, you must do to the denominator. Well, I'm going to think 1 times 2 equals 2. So whatever I did to the numerator, I must do the denominator. So 3 times 2 is 6. So I can, if I didn't know this, if I didn't have a visual, a model, which models are always good with equivalent fractions, I could just do the process. Say we had the fraction 1/2, and I want to create an equivalent fraction. I can pick any number I want to multiply the numerator and the denominator by, and I will get an equivalent fraction. So I'm going to pick 4 this time. So I'm going to multiply both the numerator and the denominator by 4. So 1 times 4 equals 4. 2 times 4 equals 8. So 1/2 is equivalent to 4/8. And I could draw a model to show that. If I had half of a pizza and so there's 1/2 right there. But then if I took that same thing and I cut it into 8 pieces instead, you can now see why 4/8 is equal to 1/2 because now there's 4 pieces at a total of 8. Just use multiplication to create equivalent fractions. You can also use division. If you have a large fraction, let's say you have 9/27, I can do multiplication, but then I'm going to get a really big number and it's harder for me to visualize a fraction with big numbers. So I'm going to use division instead. This is where it's really important that you know your divisibility rules. So I'm going to make 9/27 equivalent to something by the process of division. So I'm going to go ahead and divide by 3 because I know that both 9 and 27 are divisible by 3. Whatever I do to the numerator, I must do to the denominator. So with division, 9 divided by 3 would be 3. 27 divided by 3 would be 9. So 3/9 is equivalent to 9/27. 3/9 is easier for me to visualize. I could even break that down even more. I could say, okay, well I know that 3 is divisible by 3, 9 is divisible by 3, so my new equivalent fraction would be 1/3. 1/3's easy for me to visualize. It's one of our common fractions, and people have an easier time seeing 1/3 than they do 3/9, and especially 9/27.